If you remember back to algebra 1, when you multiply binomials, by the way, a binomial is just two terms together. So x minus 1, x negative 1. Those are two terms. Binomial here, another binomial here. And we're going to multiply the first terms together first. So first times first would be x times x, which is x squared. Then you multiply the outer terms together. X times negative 2 would be negative 2x. And then the inner terms would be negative 1 times x, which is negative 1x. And then the last terms get multiplied together. Negative 1 times negative 2 is positive 2. So first, outer, inner, last, FOIL. And then we have like terms that we can combine in the middle. Negative 2 and negative 1 would combine to equal negative 3. So the answer here would be x squared minus 3x plus 2. Does that look familiar? Stuff that you did a couple years ago in algebra 1. All right. So for the next one, we've got first times first, x squared. Outer terms, x times 3 plus 3x. Inner terms, negative 4 times x minus 4x. Last terms, negative 4 times 3 would be negative 12. 2 in the middle go together. 3 minus 4 is negative 1. So you'd have x squared minus x minus 12. Or if you want to write minus 1x in the middle, that's fine too. Either way, you end up with x squared minus x minus 12. Now, these are still quadratics. They aren't really equations right now. They're just quadratic expressions because there's no equal sign. The equal sign and something on the other side of an equal sign is what makes it an equation. So let's see. Next, we've got x times x again, x squared. Outer terms would be plus 4x, inner terms plus 1x, last terms plus 4. Add them together. In the middle, x squared plus 5x plus 4. That's what we get for that one. If you haven't done the last one yet, go and do that one on your own real quick. And then we'll talk about what we're actually going to be doing today, which is factoring, which is basically the opposite of using FOIL. Stuff that you did back in algebra 1 as well. So x squared plus 2x minus 35. Yeah. Cool. All right. Any questions about FOIL? Does this look like a familiar process? I hope. If it's not, if you need some extra help with it, come see me after school for TAT. I'm happy to go over in more detail if we need more time for that. But let's go ahead and talk about what we're working on today. And that has to do with factoring. And so we're going to be factoring x squared plus bx plus c. And it says when c is positive. Here's the thing, c doesn't need to be positive. On the back page, you'll see when c is negative as well. Most of the time, the big thing we're talking about today is not the value of c. The big thing we're talking about today is the value of a. And today we're focusing on an a value of 1, which means that your squared term at the front will not have a number in front of it. So everything today will just be x squared or w squared or n squared. Tomorrow we'll reintroduce a lead coefficient other than 1. So a lead coefficient would just be the number in front of the variable that's in the front of the expression. So in every single one that we see today, the lead coefficient, it's not written, but you could write it as 1. Tomorrow we'll take a look at other numbers other than that. So the idea of factoring, does anybody remember what to do? I know there's some examples here, some directions, but it might just be easier to remember what you're trying to do. Does anybody remember the factoring process when you have a value of a equal to 1? If not, that's okay. So the whole idea here is to try to figure out two numbers that will multiply to the number at the end and the same two numbers that add to the number in the middle. So there aren't too many numbers that would multiply to equal 16. You got 1 and 16, 2 and 8, and 4 and 4, right? Of those three options, which ones would also add to 10? 2 and 8. Yeah. So that's what we're going for. 2 times 8 is 16. 2 plus 8 is 10. And so what we can do is we can just write using basically undoing FOIL, x plus 2 times x plus 8. And that's the answer. You just separate your factors into the 2 sets of parentheses using your variable as the first term in each set of parentheses. Yeah. So how about the next one? Actually, let me ask you this question. What's the only way for 2 numbers to multiply to a positive but still add to a negative? They got to both be negative, yeah. Because a negative times a negative is still a positive number, but a negative plus a negative is a negative. It's even more negative than it was before. So in terms of numbers that multiply to 12, you got 1 and 12, you got 2 and 6, and then you got 3 and 4. 2 and 6, yeah. So 2 times 6 is 12. 2 plus 6 is 8. If they're both negative, negative 2 times negative 6 is positive 12, and negative 2 plus negative 6 is negative 8. So x minus 2 and x minus 6. It also does not matter which number goes in what set of parentheses. This could be plus 8, that could be plus 2. This could be minus 6, that could be minus 2. This looking familiar? It's kind of coming back a little bit. All right, so if the last number is positive and the middle number is positive, both factors are positive. If the last number is positive and the middle number is negative, both factors are negative. That's what we're dealing with. On the back page, once we start looking at those, you'll see the middle number is positive or negative, but the last number will be negative. The only way to multiply to a negative is if you have a positive or a negative, or a positive and a negative number. And we'll take a look at that when we get there. I'd like you to try A, B, C, and D though. Work through those real quick. Try to figure out factors that would multiply to the number on the end and add to the number in the middle, and then just separate those out in sets of parentheses with 1 factor in each set. And let's go with like 2 minutes. And by the way, if the mental math part of this is not working all that well for you, you can just write out the list of factor pairs off to the side and then see which ones work with the number in the middle. So like 6 would be, you've got 1 and 6, you've got 2 and 3. Add those factor pairs together. Whichever one adds up to the one in the middle, those are the ones that you need. So. How about C? Who's got C? Yvonne, what do you have?
X plus 8.
Good. 8 and 1. Or if you had 1 and 8, that's fine. It will not be 2 and 4 though. 2 plus 4 is 6 and not 9. Now, this next one, there's only one factor pair in terms of integer values that would multiply to 3. And since the middle number is negative, they both have to be negative. So what do we have? Yeah, w minus 1, w minus 3. There you go. That was our only option for that one. Next one here, 35. I can only think of 2 factor pairs for 35. 1 and 35, and then 5 and 7. So which one's going to work on this one? 5 and 7, both negative though. So n minus 5 times n minus 7. Bless you. All right. Not too bad, right? A nice like one-step process. Once you figure out your correct factor pairs, you're good to go. All right, flip it over. This is going to be a short lesson today. Nice, very short lesson. So let's see, the next 2 here, if the C value is negative, the only way to multiply to a negative number is if you have 1 positive factor and 1 negative factor. So let's talk about this for a second. If you multiply to a negative but still add to a positive, what does that tell you about your 2 numbers? Hudson? Okay, but if they add to a positive, what does that tell you? We definitely have a positive, we definitely have a negative because they multiply to a negative, but they still add to a positive. So what does that tell us? Yeah, the smaller the value, the number that has a smaller absolute value is the negative number, right? The number with the larger absolute value is the positive number, because if you have a negative and a positive, and the bigger of the two numbers, obviously the positive is the bigger one, but like in terms of absolute value, the bigger number has to be the positive number, because like, 5 plus -2 would still be +3. So between the numbers that we have here, let's see, 21, we only have 1 and 21 and 3 and 7, right? Chances are 3 and 7 are going to be the ones that we need for this one. So if you write 3 and 7, which one gets the negative to end up adding to +4? 3, yeah. So -3 and +7. We're going to have x minus 3 and then x plus 7. Same idea on the next one. We need a positive number, we need a negative number. The larger of the two factors has to be the positive one. Let's see, factors of 8, you've got 1 and 8, and you've got 2 and 4. Which factor pair are we using, and which one gets the negative? So 1 and 8, and the 1 gets the negative? Yeah. So x minus 1 times x plus 8. -1 times 8 is -8. -1 plus 8 is +7. There we go. Try A, B, and C on your own. Take a couple minutes on that. It's funny because a problem like C, at least in Algebra 1, that's a very commonly misunderstood type of problem for C. So I'm curious how we do on this one, now that we're in Algebra 2. And then once we get to tomorrow's lesson, I might end up just printing everybody like a 25 by 25 multiplication chart, because sometimes it's a lot easier to figure out your factors if you have a big multiplication chart and you can just slide over and figure out where they match up, which also makes the addition and subtraction part a lot easier too, especially when the numbers get larger. I think of that because when I think of factors of 42, I don't generally think about 3 and 14, even though it is 1. So there are some less common factors for certain numbers here and there, but I went ahead and wrote out all the factor pairs for A, B, and C. So for A, which factor pair are we using? 2 and 15, good. 3 and 10 would definitely be like probably the most common mistake made on this one. But 3 and 10 only work if both factors are negative and you add them together. But if you multiply those, that would give you a +30 instead of a -30. So 3 and 10 is out. 1 and 30 is not going to work. 5 and 6, no. 2 and 15, which one's negative though? Yeah, 15 is negative on this one, because it ends up adding to a negative. So whichever answer it is when you add them, positive or negative, the larger of the two numbers from the factor is the one that holds that priority. So if the answer is positive, the larger number gets the positive. If the answer is negative, the larger number gets the negative. So here we got y plus 2 times y minus 15. All right, how about B? 1 and 15 or 3 and 5? 3 and 5. Which one gets the negative? 3. By the way, some of you might already know this or have recognized this, but the answer for the addition is always going to be the difference between the two factors. The difference between 2 and 15 is 13. The difference between 3 and 5 is 2. So that will always be the case as long as C is negative. If you have a positive and a negative factor, the result in the middle is always going to be the difference between the two factors. Which is really important when we get to C. Let's finish this one up though. So we got x minus 3 times x plus 5. Now the last one, the most common mistake I see in algebra 1 is people using that. But if it's a minus b, that's a minus 1b, which tells us that our factors need to be 1 away from each other, which means those two. 6 and 7 are 1 away from each other. They have to add to a negative 1. So 7 gets the negative. So we're going to have v plus 6 times v minus 7. And by the way, you can always double check your answers by just foiling out your answer. And if you foil it out and you get back to where you started, that means you did it correctly. Any questions on those? All right. Now, something that I haven't talked about yet because we haven't needed to yet, but in general, anytime you are trying to factor anything, doesn't matter if it's a binomial, a trinomial, 4 terms, whatever it is, you should generally always look for a greatest common factor amongst all of the terms. Now, that wasn't true of any of the ones we've seen so far because the least coefficient for every other problem was just 1. So there was no common factor between all 3 terms. However, once we get down here, is there a common factor between 2y squared, 26y, and 60? Is there a number we can divide out of all those? 2. Yeah, those are all divisible by 2. So if we divide out of 2, get that 2 out of there first. So just divide everything by 2, and that'll give us 2 times y squared plus 13y minus 30. And so what's left inside the parentheses is actually basically the same thing as a from above, except the 13 is positive instead of negative. So it's the same as this problem here. Just put the negative with the other number. So you'd have y minus 2 and y plus 15. So we'll end up with 2, and then y minus 2 times y plus 15. And that would be the factored form of that one. Now, if there isn't a GCF of all 3 of them, or if you factor out a GCF, but there's still a lead coefficient in front of the x squared term, if there's still a value of a other than 1, even after you factor out a GCF, that's going to be a different lesson. That'll be tomorrow's lesson. Let's do number 5 real quick. Actually, do number 5 on your own. How about that? Solve number 5 on your own, and then that'll be it for today's lesson. Doing an account?
No,
No.
I need lazy in my end.
Okay. You can be quick?
Yeah.
Okay.
Very
Okay.
quick.
Okay. I was gonna say yesterday wasn't very quick, but today will be. Okay.
Yeah.
All right. Yeah, go for it.
No.
All right. So take a look at that last example there. We have GCF of all 3 terms. There are 5. So take the 5 out, you get 5 times x squared minus 6x plus 8. So we need 2 numbers that would multiply to a positive 8 and add to a negative 6. Both are negative. It would be negative 2 and negative 4. So there's our answer there. All right. All good? Cool. Let me get you your assignment. It's just a worksheet today. We got a lot of time to work today, which is good. So we were out of here at 10:20. So 35 minutes to work today. So if you need to finish up your test from yesterday, make corrections too. If you want to get started on corrections, that's fine. Otherwise, please be working on the assignment. There are a lot of problems to work through here, but go ahead and work through them. Yeah. Yeah, you can stand it up.
Are we gonna?
What's that? Yeah, yeah, I'll get you stand up first. Then
Yeah. So one day I got paper. Yeah.
So what's
Brother, no last thing.
Yeah.
Sorry.
Oh my God.
Six pretty much. I'm gonna make sure this is green. So, so there are 3 problems in each section. Real quick, listen up. Just so everybody's clear on the directions here. There are 3 problems in each section where it wants you to check your answer. That just means once you have your answer, FOIL it back out. And if it ends up being the same as the original, you're good to go. So every section has 3 problems to check. All right. So either get started on that, or if you have stuff that you need to take care of, come see me about that. Do the whole packet. I mean, there's a lot of problems, but I can't imagine it's going to take very long to do. So, all right. Finishing, or are we looking? Finishing. All right, we can do that. Oops.